So I think some of you already saw a few years ago, or maybe it was last fall when I was here, I talked to you about how I work at College of the Atlantic down the road, and I've been having some of my students help expand this project to look at if there's any correlations between bedrock chemistry and water chemistry. And this back in 2000, I guess it was 16, when I heard that they here at MDIBL over at Dartmouth got this first grant, I thought, great, maybe I can just piggyback on this situation and expand it by using COA students as this army of people who will go out and collect well water data for people. And I wasn't really ready to just build it into my classes or something like that. It was just an opportunity for students to do independent study projects and to spread the word, like to raise public awareness about this issue because it would seem pretty scary. So I've been working with undergrads and expanding this data set since 2016, and we've done 2 big sampling events and one sort of smaller one. And I, with Anna and Ruth Poland, a high school teacher at MGI High School, we went to the Northeast Geological Society of America meeting in Portland this last April, and we gave a talk about our experience working together on this project. And this was a section of the slide that I talked about, and I expanded it thinking tonight about what I wanted to say about what I personally, and I think my students have gotten out of this collaboration, and what opportunities I think there are for collaboration between like higher ed institutions and middle school and high schools and research centers together, not just to sort of be spokes on this wheel that is this project, but that there's a lot of give and take and conversations. And so first of all, there's so many different ways this could be built into any topic, any curriculum. I teach geoscience, but I feel like it's a great way to teach GIS and mapping, digital mapping types of things, scientific communication, research ethics, obviously like a lot of the things people have mentioned, but also in addition to some things that haven't been mentioned, risk assessment, and then temporal and spatial analysis. I'm reading this great book right now called Timefulness by Marcia Bjornerud. She's a geologist, and the title is Timefulness, How Thinking Like a Geologist Could Help Save the World. And it's a little bit indulgent for me to read this book, but the first 2 chapters are about how this problem with one of the problems, climate change, that we don't really know how to solve, is that we're stuck on this issue where we think that the Earth is just really, really old, and a lot of people think human activities can't possibly be influencing Earth processes because the Earth's really, really old. But actually, that's not the point that geologists are most concerned with. It's not so much that the Earth is old, it's just that the Earth processes span an extremely wide range of time and space scales. A wide range. Like, very quickly, earthquakes, and also very long time scale, billions of years. And that extensive spatial and temporal scale that we have to think on is like not something that's prevalent in a lot of other disciplines. I don't think. It seems to me that students come into my classroom and it's maybe the first times their brains are being exercised in this way. So I think I really wanted to sort of connect through this project with, we're having the human time scale drinking water issues with long time scale. Where did this arsenic come from to begin with? I thought it was a good way to help students kind of have to think about different time scale processes. So that's a big one for me in the curricular category. And I'm not going to talk about how I built that into my classes, but I can tell you some if you're interested. I really thought extending the resident participation seemed like a big deal for this because it is, as you all know, like just so under-tested. People don't pay attention to their wells. They don't maintain them. They tested it when they bought the house, and that was fine, and that's enough, and then haven't thought about it for 20 years. And so I think it's great to do it through the schools, and I think there's tons of people who are not going to be reached that way. And so I thought college students could go out and try to extend this to people who will not be participating in the school through the schools. This is excellent for undergraduates to have to wrestle with this data, think of data visualization techniques and managing the data, have some professional experiences. Gabby will talk about her own, hopefully in a bit. And also not just having the undergraduates disseminate the data at conferences, but also really engage in a collaborative project. Like that my students get to see how when we were at this conference together, we the different researchers talk about it. Like I think that seems like a valuable thing, that it's not just delivered to students, but they're participating in being researchers and they get to model it. Apparently, in the literature, when students can model being a scientist, they're more likely to continue on in the field. So that's an important part of the. That no, it's true, but they made those posters and they talked about it to people. That's it. I think that's really important. And then for me, I added this one since our talk. This has been huge for my own professional networking and training. I've learned so much. I mean, I'm a geomorphologist. I study landscapes, and I feel like I'm regularly at a biological lab. I went to Tom's class. I mean, it was like learning about things that I just feel like there's no other avenue for me to get training in. I don't have time working at COA to go get this extra training. And I've met so many more people. It's been, I mean, really in the last 3 years, the number one way I feel like I've been professionally networking outside of my normal go to the geology conference, say hi to all my grad school friends, drink a beer, like that pathway was great, but it was just not expanding my I don't know, original thought. So this has been huge for that. And I think like that's a whole other thing to build into grants. It's just, this is the only way for professionals to network sometimes. So these were the two I was going to talk about tonight, and I kind of said what I wanted to say about this, and I wanted to show you some of the work that my students have done. So this is where I started last year, and I said our study was to investigate the relationship between geological structures like faults, bedrock types, and also the groundwater quality. So that means we need to know about what kind of rocks are here and where are their geological structures. On this map, I'm just showing the landscape that you probably recognize. There's some mountains. Here's the island of MDI, and we're right up here. And these black lines are faults. They're old. They're places where earthquakes occurred a long time ago. And this red dotted line is where I think that there's some currently unmapped faults, because it's unlikely that this one just ends here. It actually probably connects. And if you zoom out to the whole state of Maine, you'll see there's a general northeast-southwest trend to these structures. And cracks in the ground are a great way for water to flow, but they're also a great place for minerals to grow. And some minerals like arsenopyrite or uranium oxide minerals can then be a host to ions that can get dissolved in our water that we drink. So I thought, first of all, this might be kind of an exciting way to like look for structures, but it gave me a place to target, to like send the students to one spot, not just sort of try to tackle the whole area. So we did private well water sampling for northern MDI, and over in the 2 times we sent out big sampling campaigns. We sampled about 75 wells, so 150 total community members and many COA students for the last few years. And this is the part where I can either give you the background on some geology, or we can skip the geology and go to the data and hear from Gabby. I feel like we should. I mean, it's fun. I love it, but I'll be here all weekend. So anyway, you've seen this map before. There's high arsenic all through New England, and look how nicely it correlates with the bedrock geology. So we'll just go quickly through it. You already know about that, and you pretty much already know about that. So
my favorite, I love that one. We looked at that one a lot in my class. We actually
the number of wells.
No, just the graphic.
Oh, yeah.
Visual was really my middle.
Yeah.
Like they could kind of just pointing out that I really like.
Yeah, great. Yeah.
Kids.
So I like to tell my students that like it's not personal. Geology is not personal. These rocks extend like beyond political boundaries. It's not just the state of Maine, like Nova Scotia, north. The rocks don't end at the borders, all the way down to New Jersey. If there's arsenic in your well and blaming the rocks, it's not personal. Like the Earth's not out to get you. So the faults are the result of mountain building of long ago. Just fast forward through here, and but you can have these slides and do something with them. So back to MDI here. What's that? Well, I think a lot of people saw it last year, but if you want it, I'll give it to you again sometime. I just feel like it's getting kind of late. So, and I want you to hear from Gabby. So here on MDI, the local rock that we kind of worry a little bit about is called the Ellsworth schist, and that's this orange one on here. And it was in a slide a little bit further back. But this is a rock that was deposited in the ancient ocean basin about 500 million years ago. And in this ocean, it was fairly anoxic, and there's a lot of sulfide minerals, one of them being arsenopyrite. And where do I have? Oh, here it is. So here is the green. All the green and blue are these rocks that potentially have a lot of sulfide. Well, they do have a lot of sulfide-rich minerals in them. And so we know that they are a source. And here on this map, the faults are again in black. So then the next rocks that I'm overlaying here are igneous rocks, these pink ones. And these are places where magma has intruded into the surrounding rock and formed granite or some other igneous rock. And this is really important. These are younger than the metamorphic rocks, the Ellsworth schist, and the other ones that have these arsenic-bearing or other sulfide minerals. And this relationship is really important because these magma chambers are a source of heat that when they intruded into these rocks somewhere between 300 and 450 million years ago, a long time ago, into these ancient schists that were even older, this hot magma mobilized groundwater. So there's lots of water beneath the surface of the earth. And when this water gets heated, it becomes it can leach ions out of the rocks that it's in. So this heat provides a way to get material to move from the rocks and into the water. And then that water will flow along through the cracks and through these faults until it gets to a different environment. Maybe it's a different pH or it's a different temperature. Then the minerals can form in their new location. So by having this magma intrude into these metamorphic rocks and then having faults, this is a way to concentrate some of the elements that we might be worried about. So if you have a well that's right on one of these fault plains, there might be more water around, which may be good, but there also might be more of these minerals around too. So here's where I think there's some unmapped faults, and I don't really know for sure. It's really hard to map faults under the ocean. And so we're trying to, that's like another side project, is finding outcrops that we can test it. But we just targeted this area here because this is the boundary between the schist and the granite. And it's also a place where there's, I think, some faults, and you can actually see some of them. And we just recently updated the map, the geologic map of MDI. Dwayne Braun mapped it. And so finally there's a fault right in through here. You can see it in Hall's Cove. It's pretty cool. So these are the locations of the wells, and we tried to make transects that were across here. We have a few more. Here's one, I think our furthest north sample in the Ellsworth schist. And these were done over a few years. And I should note that all the samples were collected between December and the first week of February. And this is all in the wet season. Like this is all, I mean, things are frozen, but we get the most rain here in about October, November. So the groundwater has been recharged by then. Many people were reporting to me that some of them were saying that their well casings were cracking and they're having bacteria problems. So who even knows? As to these drilled wells. I mean, this past year, a lot of people said that. And some of the people who had either shallow drilled wells or dug wells, or just they had deep drilled wells, but they were in low-lying areas, said their wells were artesian in the winter. And then that was freezing around them. This was the problem. And then some people say they have really low flow in the summer. So it's kind of like I was just getting all this information from talking to these homeowners and started thinking we should do a seasonal thing. So the next slides I'm going to show you are the maps that we made of the data. And this is, I told all these people that we're going to only publish maps that are going to obscure, like they're not going to be able to figure out where their house is. So we took time to make sure to remove any of the features that would give away where their house was, and so you can't tell from the maps. But this was a really great way, kind of way into start talking to students about some of these important things like research ethics and the IRB process, and all these things that are listed here. So here come these slides. Please don't share these widely if you use these. This was our first attempt. This was back in 2016. You can note like kind of a useless scale. I mean, why do we have all these zeros here? I mean, it's kind of a fun thing to talk about, like, do this better the next time around. But this student who made this did figure out the interpolation tool from ArcGIS. So there were 75 samples here, and she figured out how to make this interpolated map so that there weren't spaces between our data. She figured out how to take up the coastline and all the things that might give it away, and we figured, no, we can't really figure out where anything is on this map. So we added here's the geology, and you can just like maybe kind of see that there's like some hot spots right around these faults, but we only had like 2 samples here, so that wasn't that great. Well, so then Gabby came on the scene this year, and she did an independent study project that she designed a whole new sampling event based on this early work of these prior students, and it was really nice that there were already some methods established. Like we already had sampled once. She already saw these maps, so she could kind of do it all with like a clean slate in a way, but information about how she might go about doing it. And so she made these really beautiful maps. Kind of a simplified geologic map. So it's just we've got the schist, we've got the granite, we've got some faults in here. And then this one is the arsenic concentration. Now this is 150 samples, and the green is very low, and the white is the highest. And so we've kind of narrowed down that bullseye because we increased the number of samples we had up here. And you can see a slightly higher elevated along this line, I would argue, because of this fault, but we don't really know. There's some this is granite here, so pretty low in the granite as we would expect. Although there's a couple places where it's slightly higher, and actually this one is at a farm. So this is right at our campus farm, actually, and we're sampling there Monday. Again, for our dry season one. So it's thrilled. But I mean, this is a bedrock fracture network. Like anything can get, and it does. So I don't think it means, I think that we would see them in like elevated in dug wells, but I think that doesn't keep it from leaking into. And then this is uranium. So I just put these two as a comparison because while the Ellsworth schist is known to have an issue with arsenic, and the granite's thought to be free and clear of arsenic, the granite has a problem with uranium. So there are a couple people that, even though we made this project is like all about arsenic, for many people on MDI, it's like actually all about uranium, and have you ever tested your water for radon? And so a couple people did then test their water for radon and found out like, oh God, like I've been showering in this, like not so much that they need to, I mean, you don't really want to drink radon, but a big worry is this you're showering and then you're just breathing in radon. Then to treat that, it's kind of a more complicated thing than getting a bubbler. One person was told she had to build an extra room onto the side of her house because they weren't in the house with the bubbler. This turns into a huge project. So it's kind of becoming more than arsenic, especially on this island. I didn't realize, I don't know, I guess it's pretty common to check radon in air, but I don't in the water. So anyway, I don't want to give away all of Gabby's data. So what I just moved through quickly is on Gabby's poster, which is going to be up tomorrow, so you can check it out. And I just wanted to say that it's more, Gabby has been the one that did this independent study project, and she spent the most dedicated time on it. But a bunch of students through the years have helped either sample or work on the data, organize the data. And so thank you to all these students and many, many community members. And what we're looking to do next is to really do a better job with these, to figure out a way to do the forums. I think and have the high school students and college students work together. I think one year we had one here and invited the community, and I thought that worked really well. I like the idea of having one forum where the people from a region can come and share information and talk to each other. So maybe we can get together sometime here. I feel like that'd be really cool. And I think the students would appreciate that more too. And I think more if we broadened it like that. And I think that it keeps happening. We keep talking to each other, and we keep moving on to other projects that we can look into. So these are some of the questions that Gabby and others that were talking about it came up with, like, what should we do next? Like, how do these people even use the data? One of the advantages of just going out and talking to homeowners or sampling that way instead of sending the tubes home with the students is you get to like interface with people. You talk to them about like, how deep is your well? Oh, you don't know? How might you find that out? Well, you can call the driller and just here it's on the well cap. I did that with my well. And they have the information. You can call the state, the geological survey. They have, for every well that's drilled, the driller is required to send the depth, the overburden, and the yield. So you can at least get that for any well that you have the address for. And I know you don't get to have that with the students, but we did get to have that because we went through a separate IRB process, and we planned to do it this way so that we had that information. And I think it's worthwhile. And then also just what do people do when they get the number back? I feel like we haven't really dove into that yet.
Oh, but I got
What's that?
I never. My students PSA.
Oh yeah. Yeah. So no, I feel like I think it would just make me worried, and I feel like I'd be filled with anxiety if I knew the answer to how to. I don't know if they just get. I'm at their house. There's all these little kids. They're all drinking the water, and then it's like, I know you have arsenic in your water. What do you do about it? It's not my. It's not. I don't know. I don't really get to know that. So we noticed some things like when we talked to people about their filtration system, they didn't know what they were filtering. Sometimes they did. Sometimes they didn't. Sometimes we took 3 samples from one house. If they had a filter for arsenic, a filter for iron, no filter, so we take all 3 of them. Or some of them just had like a softener. And I don't know what these things do. Most of the people don't know what they do, and they don't change their filters. So who knows what it's doing, even doing what it's supposed to do. We've sampled at least what was it, like 10 wells twice, or we have data for a few wells multiple times. So we're starting to see like how are the numbers the same from time to time, and I think that could be a place to look for new directions. And then we also sampled from some farms who use the water on their crops, and some of them have high arsenic, like 48 ppb or something like that. And I don't know, is that okay? Like, at least the plant's taking it up, and then they wash the plants in the water, and then I don't know, like, is that something even to be worried about? I don't know that I like it. Great. Well, so
Yes.
So then there's
rice.
that situation that's
Rice,
like,
yeah.
so, and I mean, that's not like not monitored. Like, they're selling different, I don't know. So that's like a whole other thing that kind of came up accidentally. So I also said I was going to talk about professional development. These were the things that I think for me, I really feel like this was an opportunity for me to professionally develop. Like, for example, I made a course that's called the Professional Development Seminar for environmental STEM students. Since we're making all of these environmental students, but we don't really know what they know how to do. People don't know how to hire them and employ them because they all have this different skill set. And through this professional development seminar, it was tied to a different grant, but we wanted to engage different stakeholders, people who might hire these students in the future. And so every week we had a different group of stakeholders, and the MDI Community Lab members were our one of the groups of stakeholders. They came 2 years in a row. The students talked to Anna and Kate and Ashley. So she's not here anymore, though, right? Okay. And it was great because it was like they were working on real problems. The students could see, like, oh, I could do this. And they were one of like 10 groups of stakeholders that came through, and it was really awesome. I feel like I'm so much more connected in the community because of that, and I loved it. There's field trip and course exchanges, like Ruth Poland and I worked at Ruth worked at the high school, and her AP Environmental Science student did this awesome version of the project, and I went into their classroom sometimes with them. Ruth and I exchanged field trips. Like, she came to my professional development seminar, and I did a trip for her class. I went to Tom's class at Colby. I learned a lot from him, and it's awesome talking to students. And I love that part. It's just the exchange. We don't have a lot of that going on at Seaway. I'm a geoscientist, and I don't know. I feel like people haven't really engaged in this project with me there. But conference presentations, and then these maybe future spin-off. So let's hear what Gabby. Oh, this was that development class. So Gabby, I asked Gabby these 3 questions when. Wednesday when I said, hey, you should come to this workshop. Can you respond to these questions? So coming up here and telling them what you learned. You can stray from it, but how's it going? Okay, thanks.